This is Lab Report Writing 101, an overview of scientific writing with Miss Henderson. In this program, we will cover different concepts for lab report writing, such as language, writing a title, generating a testable question, determining and stating relevance, what is background research, how to make a claim related to the purpose, designing and writing a lab procedure, creating a data table, completing data analysis, and accepting or rejecting your claim. So let's talk about language in science. Writing in science is different than in English or history class. In scientific writing, no personal pronouns are used. Personal pronoun examples include I, me, my, we, us, and our. These should not be used in lab report writing. Instead, you should make the pronouns impersonal, and more on that in Lab Report Writing 201. Lab reports in all scientific writing are written in past tense. This is because at the time of the writing, the experiment has already been completed. So be sure that when you write a lab report, all of your tense is past tense. Words that are not past tense but are actually future/present tense include will, going, will be, will find, etc. So those are all examples of future tense or present tense, and you would not want to use those. The only exception to writing this rule is when you're writing questions for future testing. Because if you're writing questions for future testing, then you haven't done the testing yet, so you would want to write that in future tense. So you could use the word will. That would be an example of the only place where you would want to use future tense. So only use future tense when you're writing further testing questions, and that would be at the end of your lab report. Everything else should be past tense. So here are a couple examples of not so good scientific writing on the left and then better scientific writing on the right. So you don't want to say I. Using the would be much better. Here it says our group found that. You don't want to use our because, again, that is a personal pronoun and we don't use those in lab writing. But you could say, based on the data gathered, it can be concluded, and that would be an example of good scientific writing. So you want to stay in this area to the right over here. And more on that in Lab Report Writing 201. How to write a title. A good title efficiently tells the reader what the report is about. It may include such information as the subject of the experiment. So what is it about? The key research variables, the kind of research methodology used, and the overall findings of the experiment. If your title is too long, that means it takes up more than a line, you can reduce it by taking out any non-essential words and phrases. If your title doesn't have enough information, some ways to get more information would be make a list of keywords related to the experiment, such as the scientific concept of the experiment, important variables, procedure, and overall finding. And use that list to come up with ideas for further information. If your title is a complete sentence, so with a subject and a predicate, rewrite it so that it is not a full statement, but more like a phrase describing the experiment. So your lab report title should be specific to the lab performed, it should be in bold, and it should have important words capitalized. Words you don't have to capitalize would be and, or, to, from, and the, unless the is at the beginning. So would lab report be a good lab report title? No, lab report is not a good lab report title because it needs to be specific to that lab. So lab report could be written for any lab report. You need to have a specific title. So for example, for the separation of a mixture lab, you could write separation of a mixture of salt and chalk. Lab report. That would be fine. If you want to learn more about this, go ahead and click on this website and there's more information about writing a good title there. Generating a testable question. Questions of science need to be testable. They need to be what we call experimental questions. A testable question is a type of question that is used by researchers and preferred in science. Testable questions require a more in-depth answer, and the answer can only be found through testing, aka lab experimentation. Remember from the How to Do This Science Prezi that Testable questions would not have yes or no answers. So, in the separation of a mixture lab, this question would not be testable. How can a mixture of salt and chalk be separated? This question does not require prior knowledge. Well, you need to know what a mixture is, but do you need to know any separation techniques? No, because that's what you're asking. So, you wouldn't have done any prior research. However, it also does not require testing to answer it because you can just look up the answer that you can filter out the chalk and evaporate the water off the salt. And this was also discussed in class previously. An example of a testable question related to the purpose of the separation of the mixture lab would be how accurately can a mixture of chalk and sand be separated using filtration and evaporating techniques? And if these techniques are used, will the mass of the products be the same as the mass of the reactants? So, if you need a little bit more help on generating testable questions, here is the link to the How to Do the Science Prezi. Go ahead and go there and learn more about testable questions. Relevance. This should be about how it actually relates to your life, as in the big picture, not how your lab report score will affect your grade in chemistry. An example of how the separation of a mixture lab relates to your life would be the process of separating the dirt, straw, and hay from wheat in order to make flour. This is because flour is used in lots of food products such as cookies, cake, bread, and pasta. So, there you can see that you are benefiting from the lab technique being able to be done in industry so that you can have things like cookies and cake and bread and pasta and all those delicious things made from flour. So there's your example for relevance. So this is the area we want to stay in over here with our good examples. A not so good example would be this lab is relevant because I have to do it for my grade. If you're mentioning your grade in your lab report, that's not quite what we're looking for in scientific writing. Now, we do want you to be interested and, enjoy and think labs are cool, but the lab report is not the place to discuss that. And my teacher said I have to is also not an example of relevance. So those are your non-examples to the right, and your good examples are to the left. Let's move on to background research. This can be information you learned in class about the topic, and you may also have to do some research on your own. And how to determine credibility of sources is coming up in our next segment, which is Lab Report Writing 201. So let's talk about a real example here. For the separation of a mixture lab, the background research was provided in the separation of a mixture Prezi. You can always use material learned in class as your background research. Just be sure to cite your sources, and again, stay tuned for that in Lab Report Writing 201. Moving on to making a claim related to the purpose. It is important that you write down the purpose of the lab so that you can design your question and write your claim based on the purpose of the lab. Be sure that your purpose is within the scope of what we can test and determine in our lab. So it shouldn't be something that you would need a professional lab setting to do. So the claim must be related to the purpose of the lab. This should be your answer to your testable question. You should complete the testable question and claim prior to completing the lab experiment. A claim for the previous example of a testable question would be a mixture of salt and chalk can be separated using the techniques of filtration and evaporation because the chalk can be filtered off and the salt can be evaporated. The mass of the products is expected to equal the mass of the reactants because, according to the law of conservation of mass, matter cannot be created or destroyed by chemical or physical reactions. So, there I have answered the testable question, I've made my claim, and that claim is based on evidence. And that evidence in this case is the law of conservation of mass. So, basically, what the law of conservation of mass here is saying that you have to have as much at the end as what you started with because you're not creating or destroying any matter. Now, is this something that we can do in lab? Yes, it is because we can use the techniques of filtration and evaporation. Let's move on to designing and writing a procedure. So your procedure must be in stepwise format. What does that mean? That's numbered steps listed in order. So you shouldn't have a giant paragraph as your procedure. It needs to be complete and accurate. So all steps you take in the lab must be included. It needs to be concise. What does concise mean? That means to the point. So you don't have any extra words. And I like to call those extra words fluffy words. So any sort of descriptive imagery, you're going to go ahead and save that for your amazing English paper. And we're not going to use that in science because scientists like things straight up and to the point. We don't like to have to read a lot of extra words. So, in labs in chemistry, you will design and carry out your own procedure, and we've discussed the reasoning and the methodology behind that previously. So, when designing the procedure, you should know what the purpose of the lab experiment is and write your procedure to achieve the purpose of the lab. When writing your procedure, think of another student following your procedure. They're going to need everything step by step by step. So, could they use your procedure? Could they complete the lab and get the same results as you? This is an important component in communicating science that real scientists do every day. So, a really important component of science is that scientists can share what they did and what they found, and other scientists can use that to repeat their experiment, and then they can see, well, is what you found correct? Or are there some areas for improvement? Or do we have more questions? Let's talk about creating a data table. So some of you might be using Word. In that case, you're going to look at the left side. Some of you might be using Google Drive. So in Word, there's a top menu bar across the top. You're going to click Insert, and then there's going to be a place to do the table. And you just decide how many rows and columns you need. And don't forget that you need one row for the titles of each column. Now, if you're using Drive or Google Docs, there's a top row menu. You're going to click on Table. That's going to provide you with a little drop down menu, and you're going to select Insert Table. You're then going to drag your cursor to the right to highlight rows crossways, and then you can drag your cursor down vertically to highlight the number of columns. If you drag your cursor kind of diagonal down, it's going to highlight the rows and columns together. And don't forget you need one row for the titles of each column. In both, to add a new row, all you have to do is be at the bottom right row and press Tab. That'll add a whole new row all the way across your table. And more on creating and formatting data tables is coming in Lab Report Writing 201. Data analysis. There should not be any raw data in this section. All of your raw data is going to go in your data table in your data/evidence section. Data analysis can be, but is not limited to, percent error and percent composition. All of the work must be shown. Let's talk about your conclusion. Do not write, I accept my claim because. Why is I accept my claim because wrong? Well, it's using one of those personal pronouns that we don't want to use. So instead, we could use the good examples such as, based on the data, the claim is accepted. And then you could go into discussing the specific data because you need to cite specific data. However, you don't want to cite any raw data. So you shouldn't be saying the mass of the chalk was 2 grams. No, you want to be referring to your analyzed data. So for example, in the separation of a mixture lab, you would want to be referring to your percent error data. In this section, you also want to discuss possible sources of error that could have occurred in the lab. You can discuss the sources, and then it's a good idea to come up with potential solutions for those possible sources of error to show that you really understand what you're writing about. You also want to pose further thinking questions which show a deeper level of thinking, and these need to be levels 3 or 4 on the depth of knowledge wheel. More on that to come later. So hopefully this helps you get a general overview of writing a lab report, because writing lab reports is challenging due to the fact that writing in science is very different from other types of writing. So please use this to help you, and be sure to come back for Lab Report Writing 201.